All right. Thank you, everyone, again for joining us today. Today, we're going to be talking about shipping faster with AI, focused on our area of platform engineering. And we're joined today, as always, by the host of this series, David O'Hara, as well as our expert, Aman Juneja, who will be helping Dave understand how AI can impact the platform engineering aspects of our ongoing project. So I would draw your attention to the Q&A feature of the Zoom client that you're in. Please feel free to use that to submit questions, and I will give those voice at an appropriate point in the conversation. And with that, I'll turn it over to Dave.
Excellent. Thank you, Tim. And thank you, Aman, for joining me for this session. I look forward to hearing your perspective and seeing how we can leverage AI. Before we get to that, want to call out this series. So for the month of October, we've been running a series on how to ship faster with AI. We're actually taking a feature for our platform, our internal platform called Engage, and we are walking that feature through each stage as we build it. And we're dog fooding, right? We're using this for our own stuff and showing you the tools and the ways we use those tools to deliver a feature. On October 1st, Bill Curry and I set the stage with the state of AI and where we are. And then David Sandoval joined me on October 8th to show us how to use UI and UX AI-enabled tools to give us the design and the look and feel that we needed. Then last week on the 15th, Eric Ziebenek had a chance to show us how to leverage Windsurf and those AI-enabled tools to build that feature into the platform. And I'm excited to hear from Aman today about platform engineering and infrastructure as code and the way that we can leverage that. And then next week, Rich McCraw will be joining us, and we're going to talk more about analytics and insights and ways that we can use data engineering inside of our platform. So I hope that you'll join us next week. And if you missed any of those prior sessions, you can find those on our YouTube channel. Go back, watch those, watch as we progress and deliver this feature utilizing AI. So for today, we're going to talk a little bit about the state of platform engineering. Aman's going to show us some of the platforms and some of the tools that we can use. Then we'll dive into that Engage feature, right, as we demo what it is we're doing as we're building out this feature. And then we'll have a kind of a wrap up. So I look forward to it. So Aman, thank you. And let's hear about the current state.
Thanks, sir. Thanks for having me here. Yeah, I think starting with platform engineering, I would like to just bring in the context, like what platform engineering is and where do we stand when we see it at the entire org level. Now, the goal of any platform engineering team is to kind of build a foundation layer, reduce the developer's cognitive load, make sure that releases and everything happen with all the governance, policies, and everything baked in. Now, how do they do that? They kind of create a bridge between two of the major teams in any organization. That is engineering team, which built out the core features, development, front end. They have seen some gist of it in the last couple of webinars. And then there's an infra team, which brings up all these hardwares, be it on cloud, be it on-prem, and whatnot. Now, platform engineering team kind of sit in between, comprised of DevOps, SRE. They could be, again, developers who are kind of enabling these scriptings and all those tools. Then you have project managers and all this stuff. So it's same like typical product teams, but kind of a glue between your infrastructure layer and the layer that brings your features. Now, when we say about platform engineering, what is different that they do? Like I said, they try to reduce the developer's cognitive load. And why is that required? Is mainly because in the last 6 to 8 years, we have seen the complete spin of cloud native toolings. There is a tool sprawl for everything. You would see a tool, even if there is a small change, it's like just reviewing like PRs or just linting the code, everything has a separate tool and everyone has their own opinion, choices and whatnot. Now, platform teams try to kind of bring it as a standardized tools and workflows so that be it any team across the org that tries to release or create new feature, they get those policies, things baked into it so that we don't have any surprises when any new feature go into the production. You don't. So that kind of ultimately reduces the friction between the all the upper and the bottom layers. And give the developers a kind of a self-service infrastructure. They come in, they build their code, they make the changes, and then whatever it takes to take this code from dev to production, that is all kind of baked into a platform. Having said that, what are the core elements every platform team usually have? Of course, there will be a lot more things the platform team do. What I'm trying to highlight is kind of like a core elements that every platform engineering team has to do. It is infrastructure as a code, like we're making sure that whatever you're bringing up on cloud, on-prem, it is coded just like your typical product development features so that you can bring the same infrastructure anywhere. You can use tools like Terraform, Azure Bicep, AWS CloudFormation, and many others. You should have a CI/CD pipeline. Like I said, complete standardized workflow, coded something, how it reaches to production. That is all baked inside your CI/CD pipeline, how your code is built, stored in an artifact, and then releasing it into the clusters. Then comes your observability and monitoring, which gives you insights of the systems that are running in production. Anything goes south in production, how do you get to know about it? That's all big, your observability, monitoring, incident handling, and all this stuff. Security and compliance, very critical. Should be part of, some would be part of your CI/CD, some you even when you use your systems, and some would be part of your runtime as well. So all the different layers have to enforce these things. And ultimately, where does all these things glue up is your developer portals and service catalog. So whenever a developer uses a platform, he needs to kind of have all these features available to him so that things that are quite generic and needs to be there for every release, those are kind of baked into your workflows, your CI/CDs. And then things that you kind of need to request new, like probably you're spinning off a new project. I want to create a new repo. I need access to a machine. I need to get onboarded to CI/CD tool. These kinds of like things come into your this developer portals. Developers should be able to request these things easily. They don't have to create 10 other tickets to just get the access to the system. So that ultimately helps all the team members to reuse things, enable self-service capabilities, and maintain these golden standard paths.
So what do you mean by golden path standards?
That brings us to this slide, why it matters, everything. There are a lot of things we are talking about. We started from tool sprawl. We said we will reduce this tool sprawl, create a standardized workflow. But how do you measure it? What does it really impact? So for that, industry uses something called as DORA metrics. Now, these are out of the State of DevOps report. How ideally you should do your DevOps research and assessment metrics. And that's what DORA metrics cover. And DORA metrics is all about 4 critical things: deployment frequency, leak time for changes, change failure rate, and failed deployment recovery. Now, deployment frequency is more about how frequently you can deploy your thing. So I think in the last 2 webinars, what we have seen is how David took a snapshot or just an idea and created the complete wireframe, Sigma, and all this stuff. And then Eric took that and created a complete feature. So that kind of accelerated their journey to build up the feature. And now the part is how you can deploy it too quickly. So if you can build faster, then the bottom layer is your platform that has to handle to deploy it faster. So all things glue up together to make sure that deployment frequency is for elite and high performers. It should be multiple times per day. You should be free to release if you're using a microservice stack, release your services as and when your changes are ready and ready to go to prod. Now, lead time for changes, it's about when your code is ready to get deployed to production. And that does all get tied up again to these core elements of CI/CD, security, governance, policy checks. Because a lot of time, a lot of tests happen manually. Your developers committed the code, but you have to do a lot of testing manually. CD is not automated. You only build the artifacts, but you have to deploy it manually. There are a lot of approval gates. Policies are not enforced. People have to check with 10 other teams to get a validation that can I deploy. And that's kind of really make harm this lead time for changes. Ideally, it should be less than 1 day is what the target for elite or high performance is. Now, change failure rate, how many times your deployments get failed? You move to production, how many times you have to kind of fix it back again, the rollback happen. Again, ties it back to your CI/CD, how good it is, and how good is your observability and monitoring. You were able to capture those issues. You were able to fix it back because your CI/CD was good enough. You can just make the change and you kind of able to release it faster. Again, target is 0 to 20%. And failed deployment recovery time, the last metric, it takes the time it takes to recover from a failed deployment. Again, ties it to your observability, incident management, your CI/CD, your infrastructure as a code, and then your development practices. So you identified you need to have a good incident management system in place to know that you have buggy code released. You have to report it, or you go back to the previous version, or you make a hot fix, or you release it. All those things should be done within less than 1 hour time window. And that is only possible if you have all these core elements done very well. That's how fundamental is, and that's how usually teams are doing it. And since our first webinar, we know that AI impact is on many of these tasks, and we target the tasks that are kind of collapsible. That is something where AI can help you kind of speed up. We'll not say that we are at the stage where 100% of this can be done by AI, but the goal is to create AI powered platforms so that AI helps you do many of these things in a faster manner so that you can focus your time and energy on building out something new or identifying where human intervention is really required. What are the top areas that we think AI can help in addressing these collapsible tasks? I think infrastructure, code generation, and automation, that's a topmost feature because you use things which are kind of have a very well-defined syntax. Biceps has their own DSL, Terraform has its own syntax, CloudFormation has its own syntax. And all these LLMs are very good at these documentation consumption, and then they already know about these syntax, and they can help you write initial boilerplates about it. You don't have to spend too much time on creating those changes. CI/CD pipeline, same idea, same methodology. They are aware of most of these template structures, how the pipeline runs in Azure DevOps, how the pipeline runs in GitHub Actions. It's already there. You have to use this or leverage it in the right fashion to make sure that you add your changes quickly, you validate it, and then you are able to release it faster. Automated root cause analysis or intelligent alert routing and prioritization, it's all tied up to your observability. Many of the alerts that you usually get, be it like a spike in the CPU, spike in memory, these are kind of well-defined alerts. Sometimes you need detailed troubleshooting. Sometimes you have to do a scale up. You have to do capacity planning for that. And these things, definitely LM can take it. There are many tools in the industry that are currently showcasing the values in that. Security side, we can not 100% say that it can go and remediate it, but yeah, it can definitely come up with the recommendations. Then we are seeing a lot of PR reviewers tool that can be added to your repos. You make a change, you create a PR, and within those PR, you can see security bugs that your code introduces. It can even highlight in the existing repo as well. So you can run the scans, you can run it over the containers. There are tools, but it can assist you in identifying even the newer vulnerabilities as well that is not yet added into those tools. And the biggest area where I think most of the people are already using, and it is making a biggest trend, is documentation and book generation. You don't have to depend on a team to come and show you and give you the guidance on what the system is. Use LLMs, use these models, use the coding agent tools. You can generate your own documentations and book generations, have your own well-defined understanding based on the flavor or way you like it. And some of this we'll see next in the demos as well. I think we have seen in the last few webinars, we are trying, our business problem is to create a drip chart. We are trying to convert this feature where we have skills and roles mapping. And we kind of created a complete new feature that allows us to create this presented in the new drip chart feature. So what we're going to use today, we're using Cursor. And the reason for that, I've seen you can use Vincent as well, like you have seen last time using that. And David was using another tool for the UI things. Again, this is talking to the LLM model Cloud Sonnet 4.5. Our goal is to kind of address some of the areas that we feel could be important, be it on the architecture or documentation side, be it on the pipeline side, or something on the governance and CI/CD side. So first thing that usually anyone who joins the project is new to the project or want to understand the project, or any SRE or platform team member wants to have a context of the project, like where they are getting into, how do they understand the system. Usual way is to book a meetings with people who are already there, and it takes time, or you need to have a very good documentation in place to understand that. But many of these cases, you don't have those things. And that's where you can use something called as C for context diagrams. And we are targeting currently the drip chart feature, but since our app is not that huge, like we are not running microservices, we'll see the whole stack as well in it. What is important here and what is this prompt does, you need to give it a persona. I mean, I'm focusing more on the platform engineering kind of persona because we are coming from that way, and we want to understand more from the perspective of what are the components involved here. Right? What do we want to understand? What kind of services are there? What are external tools? What are the platform tools? Who is the users? And those things we're trying to understand. Again, you'll see prompt is too big. There's a context and all this stuff. You don't have to write it on your own as well. Even this first take of generating this context, that is also something that you can directly use Cursor Chat to generate that. What is important is your persona setting, what you want to know and from which background you are coming in. What do you want to get from it? Probably external actors, external systems, key interactions that you want to know. And how do you want it? You want it as probably a plant UML or C4 plant UML. Relationships should be clear. You don't need anything funky, no emojis, no icons, not too many comments and all this stuff. What did we give you? It's something like this. So you wanted to understand the platform. Now we are running this as like an internal stakeholders platform, right? So at the center is our platform where all the features that live. We have this engagement learning, drip chart feature, whatever we build right now. All those things are baked inside this. It has external systems where authentication happens from Azure Active Directory. All the data is stored in Azure SQL database. Again, that is an external system, so running on Azure. All the telemetry goes to application insights. What kind of users use the system? I'm consultants, manager, HR administrator. So as a platform engineer, I joined the team. This is the first thing that I wanted to know about my platform where I'm going to make my hands dirty. This helps me understand this is my platform at a very high level. Now, next thing I wanted to know is because I'm going to work on more on deployments or making sure this gets released, I wanted to understand the container part of it. I know that from the initial understanding that this is running in containers and all. Again, same structure. I'll go with my persona of platform engineer. This architecture layer, you can either take it from the last diagram that you have generated, or you can again generate it directly from the coding agent that you need a context of the project, and that will generate it for you. What you need is something that you want to have clear deployment locations where it is being deployed. Those deployments should be grouped so that you know that what common services are being used here. I want to know about the technology stack labels, any internal API architectures, anything that I should be aware of around the communication protocols, because that's what decides how I'm going to deploy it. What kind of CI/CD model will work here? What kind of infrastructure as a code will be required? And lastly, I need the outputs. Again, be very clear what you need. Don't add any emojis icons because LLMs has an habit to add these things to make it complete. Now, what you will get out of it is a complete architecture of it as a UML. So you now know that how do users access it? It's via the web browser. It's an Angular app that runs in the browser. It is hosted in Azure App Service. Then you have your web APIs that's again hosted in the Azure App Service. Then you have Azure SQL databases, all part of Microsoft Azure, Ocean ECS. And then some insights on how the web APIs, if an application is a layered model, you have application layers. For drip chart specific, it was being added into the drip chart app service that I think Eric showed in the last webinar. All the domain layer details, infrastructure layer details, like how the DB migrations are being created or how the DB connections are happening, or that it is there. Same goes for your Angular app. You have to know what it is. It's more of like a static assets deployment. It's a static app. How do you build it? What are the contents? High level. It is deployed to Azure App Service, or you can even host it on the Azure Logs or Azure Storage Static website. And again, Azure Active Directory is completely out. You have to only focus on the configuration part of it, not on the deployment side of it because it's a managed service. And then application insights, again, it's a managed service. So you have to more focus on the configuration. How do you talk to application insight? Or what kind of alerts you want to create. That will be the focus area for these two layers. With that in mind, now I know first the context, what my platform is, what are these components of it, where I'm deploying. Next thing, probably as a engineer, I want to know how does these drip chart feature communicate. I want to know the sequence diagram. I want to understand how this feature works, who calls who, how the communication flow works, so that I am configuring it correctly, right? Same idea. You have these persona, you create your context. And again, this prompt doesn't need to be always so overwhelming. You can reduce it if you don't want too much information. If you want too much depth, so you have to give it more and more details that you're expecting. Probably like what tasks do you want to know? You want to know active systems, flow steps, key details that you want to show, and error handling feature. Most of the things that will be generic and you might have already noticed in other prompts as well is something like context generation that can definitely use the coding agents to give you a context of the current repo. And same goes with your success criteria. What do you want to clearly do? Output format can be generic across all these things. So you can probably have a template as well and then just modify the things in the center on what kind of diagram you want to generate. And you can use somewhat the similar prompt templating model. You don't have to write everything again and again. Now, here my focus, like I said, was to understand how this drip chart feature is communicating and how we are getting the entire feature working. What this prompt ends up giving me is a complete sequence diagram where it shows as a user where it starts. If I want to view my drip chart, I clicked on those feature. It hits out to Angular SP app. Then it calls the ASP.NET Core API, which goes on to validating if I'm authenticated or not to Azure authentication checks with durability token and all. And if that goes fine, then it goes deeper into the with service layer or application layer part. And finally, it goes to the DB context where we are using EF Core, like Eric explained last webinar as well. And finally, it hits the Azure SQL database. That's the communication flow that I'm seeing for how to use my view chart feature.
Just for clarity, like the services that are listed across the top, the services and the context, that's actually using the names of the services and the context inside of the code base, correct?
Everything is picked up right from the code base, how they are written. You have this core API in the north middleware, and then drip chart app services, what was created specifically for the drip chart feature. We have this calculation service that is kind of a domain layer. And then finally, we have the stakeholders DB context, which helps us connect to the Azure SQL databases. Now, this gives us the initial skills and the proficiency for the particular employee. And then we do another call, which makes sure that we get role mapping to the skills. So now we know that for this feature, we are probably using around 2 SQL calls. We're connecting 2 times to SQL. Azure SPA connects to Core Web API. And that's finally give us the response back. So as a platform engineer, I know the entire flow of this feature now. I know who is talking to whom and how this context is happening. That is where AI accelerates understanding. You don't need to wait for someone who built the feature to document that feature, because this has been a usual flow. Teams depending on the another team member that has built this feature, you have to document it and then only we understand it. I think that is something that we can definitely accelerate. And so that any platform team members look at the new feature that they have to deploy, they understand the flow, they confirm with the team, a small probably call to just confirm on these charts or async conformity as well is fine. And then they can plan how to release this. Is this already there in the pipeline that can handle this? They can give a go ahead to it. Or it is something that they have to add something new here for that. This is the first part where we are generating using C4 or UML diagrams to understand the context, architecture, and then the sequence of the communication. Now, the next part that usually comes after this is when you know what your feature has been developed. The next part is how do you want to release it? And usually for most of the organizations, we have this architecture decision records. Now here, I'm taking an example of, let's say, the caching strategy, how we are using the caching strategy here, because usually any new feature is built. We need to know how good or bad it is, how much load it can handle, what cost impact it might have. And based on that, we decide what kind of strategy we are using. Like I said, same structure I've used. I'm not tried. I'm not. The reason for using the same structure is you might spend a lot of time thinking a lot about prompt engineering. If I would have done it this way, if I have done it that way, that would have impacted a lot. Yes and no. It can impact, but it can also delay your progress as well. Like I said, AI-powered platforms are, and so that if you can even make your prompting structure as something templated that works for you, that can also be a good start. So again, same, you set your personas, you have your context, you have your drip chart feature that requires kind of like context of it, like it role skill mappings. What are the expected load that we are seeing? Probably 500 consultants using it for 5 views per week. These are the kind of roughly request volumes. And some business development roles, query costs, 40 to 60 milliseconds database pay. What are the options we have considered? I can just quickly write about it, like probably no caching in memory, or we can use distributed cache, or we can use static data patterns kind of baked into the deployment and all. The team did the choice of in-memory application cache because this application is mostly used for internal purposes. So unless and until it reaches to a point where we are burning more of the compute capacity and we could offset that with this cache and reduce that, then probably it makes sense to invest in an Redis cache, which is going to cost us quite a lot. Till that time, it's fine to have an in-memory application cache. A small delay is fine. We can burst this. Admin can have the feature to burst it, right? Now, obviously, this is your rough notes. You might have discussed it with your solution architect, platform architect, and this is all your rough notes. Now, when you go to any ADRs, what teams need is a clear context on what is decided, where it is decided, and why this choice has been made. And that's where this generation kind of helps to create you complete detailed markdowns. It can put all the format, and the interesting part is you can even add implementation notes, like where the code location is, how does that be implemented, are there endpoints to kind of flush it out, your role mapping cache, and you can expand it to any level. After the initial context, you can add the calculations for the cost pricing, scale rollout, when does it make sense to move out of this, let's say the request grows to a certain number, like we said, 10,000 per week, we can just remove out of it and we go to the latest cost calculator. we can use the Redis cache. So that's another thing you can use it to accelerate it generally to create ADRs after it's a decision records. You know the context, you know the communication patterns, the choices that have been made during this entire thing, and then you can bring it up so that we get a go through from the entire stakeholders, like whether this decision choice was right or wrong.
Yeah, so I really liked what you did here with this ADR. You know, as we're building a system, so often we're making decisions as we go, and the future us would love to be informed by current us. Why did we decide what we decided? Like, what went into that decision? And so I love how you're capturing this. So whether it's future me looking back on the system or some other teammate that's trying to understand, well, why was that decision made? The fact that you are capturing that is really meaningful.
I either spent a lot of time on this or have neglected this because documenting is the most boring part. And that's where team don't spend too much time on it. And if you save these things, you can just put your rough notes, add the persona, add the context, and that's all it needs. And then it can generate all these clear formatted ADR records for you. I'll probably 30 minutes to an hour of human intervention to polish it up a bit or remove things that are not relevant and fact checking it. That's all it's required here. We'll move to the second part where you can use AI-powered platforms is around the pipelines or some around infrastructure as code. This platform, we already have it. So we have the pipelines built up, we merge it, it's change and release. Like we have Azure App Service. But again, like I'm joining in, I don't know, probably a health check is missing. So that is a feature that I wanted to add in this pipeline. My goal is that this deployment pipeline that I'm using, it is building an ASP.NET Core Web API. It runs migration. It deploys to Azure App Service. That is what I understood from the current pipeline that I'm using. Looking at this pipeline, I understand that I have a build web, I have AF migrations. That's the current state that I have. But what I wanted to add is, I see that the problem is if I deploy it and if the services are not running healthy, then it might cause a problem. We need a way within the pipeline to kind of do an health check and make sure that we only validate or roll back based on that. My requirement is straightforward. I want to add a new pipeline stage. I want to health check logic. I probably use AQL queries to kind of query out whether my service is healthy or not. And based on that, I kind of stitch it. If it passes, continue. If it fails, then just roll back the deployment. Again, a lot of things feel that an app service can do it by itself. And many of the platforms, if you're using Kubernetes and all, it might happen that your service is healthy, it's running fine. To boot it up, your health checks pass that we have configured, but after the few minutes fail. So probably adding these health checks here or at the observability platform, both make sense. It can be during the deployment or it could be post-deployment as well. Both ways you can use. For this output format, I wanted like a stage that is added and some example structure I have filled it in for that. The same deployment file that we were using earlier, build web, build EF, and then deploys it. It deploys the API, and then it added the last stage, which is the validate deployment. And it adds a quick health check to it, which is using the scripting model. And it is kind of just going in, making that query that whether the request, the chart feature is up. It is using their endpoint to communicate to it. And if it passes, it moves the deployment healthy. And if it fails, it kinds of fail the health check status and it kind of pulls it back. A lot of this probably might take a lot of time to write it, or you don't have to do it. But with this, you have to only drill down your idea, what you're trying to achieve, and then you have to just put into this. Some fine tunings might be required to it, but you can get to these scripts very quickly, and you can add this kind of layered model to your CI/CD pipelines that any deployment that happens, I want a health check to it. Currently, we are targeting drip chart feature, but the idea is you can make it generic for all the API endpoints. You can add kind of like a directory or list structure to it that these are the API endpoints I want to target that are critical to the business. That when I release a new feature, I don't break a feature that was already working. That those things can be added into these pipelines quickly. Similarly, if you look at the tagging, this comes from the cost perspective. Currently, this platform, and we have a streamlined team, but if you look at the microservices kind of architecture, a lot of teams are working parallelly, consuming the cloud resources. And it's very often that you'll see quite frequently that teams are just adding new resources every other day. You don't get sense when the cloud bills get shot up, right? That's where the tagging comes in so that we can make the teams accountable. You have this FinOps mindset. Every team knows what they're spending, what they're using so that they can estimate for their features well. And that's where you can add the resource tagging feature. And that is very critical. Usually for platforms, this should be baked inside your platform. It should be part of your CI/CD workflows, any infrastructure as a code that is happening, any CI/CD, anywhere you're creating a new resource, be it your cloud resource, be it your deployments, you need to tag it. You need to make some team accountable for it so that we know that what is the cost of that particular feature or what is the cost of that particular service that we're using. And that's what I wanted to achieve with this. I know that we're using for current infrastructure as a code. We have the starter.bicep, provisions some storage resources, so storage functions. It has provisions some servers, web apps, and all that we have seen in our C4 diagrams right now. We are missing the tags here. We don't know who is accountable for it, which is the dev environment, which is the prod environment. All those things are completely missing out of it. And that's what the requirement I had with this. And what it will give out to me is probably a complete bicep file. This is the starter bicep that we just looked at. And now it has those things added to it. So we have this variable model where you can add tags. You can create your parameters file based on different environment, and you can pass your default tags that needs to go. And then based on the pipelines that trigger it or the teams that trigger it, each service will have their own tags that are defined again in the pipelines as well. So in a way, we get all the default resources tagged. None of these resources are orphaned. Whenever we want to make a report that which team is consuming what, we have these tags to kind of build out that report. Next thing that usually every platform targets is the security part. We have these tags. We know who is accountable, who is the owner of these resources. We know how to release it safely with the health checks and all. But next is the security part. We want to always, every team after a certain stage has to, or from the start, has to focus on shift-left security. Like right from you are doing the build, you need to know if you're using a lot of dependent packages that are vulnerable or any other external packages that are vulnerable. Because probably you can check your own code, but it's always sometimes risky to use the dependent packages. Like we're using Angular right now. It depends on a lot of open source libraries. Same goes with other .NET APIs as well. Simple feature I wanted to add, I don't want to create another tool sprawl. So probably using the native features to just check the NPM dependencies for vulnerabilities, NPM audit feature. And same goes with .NET packages. Just scan it and use it. Again, this is just a lighter version, but you can add 3V, you can add container tools like 3V, Anchor, Clear. You can do SASH like SonarCube, OS dependency checks, and many other tools that you can bake into this pipeline. And same you can add here, that whichever tools you want to use, you will get a default skeleton structure for it that you can enhance. Requirements that I have should be very clear that scan the packages, pass the results, generate a report for me, and that's kind of like an example script that how to do that. What it will come out with for backend build, we have this security scans added. So it runs the security scan stage where all it does is kind of like do that vulnerability scan, take the vulnerable packages. Once it's out there, it gives you write the script because probably that will just give you a dump of your command out, but you can present it what is critical, what is high, and what is moderate, because that is what you have to target primarily, so that you make sure that any of these risky or vulnerable things don't reach to your production. And that's where teams can decide after a certain stage, you want to block the builds that none of these vulnerable packages are reaching to production, or initially you start with kind of like and just kind of like a suggestion mode, and once teams get to this practice, you enforce it by enabling it that I'm not going to allow it to release more vulnerable packages to production.
So Aman, with the security scan like this, is there a standard like set of things that you're looking for? Is there maybe like some recommendations? Like how do you decide what goes into this aspect?
Okay, so the kind of must have is like you don't do anything that is a high vulnerability. And definitely you can align it to even the compliance packages as well. So there are benchmark tools like CIOs benchmarks. There are tools for SOC 2 compliance. We can do scans for like certain compliance as well, right? One way is you only enable a compliance oriented scan, and then you kind of only check for those vulnerable things, and you don't allow them to go because you have to adhere to that compliance as well in the production. The other way is if you are very early in your journey, just make sure that you're not releasing anything that is critical or high vulnerable. A medium, and that is fine because you are an early in journey, you want to release faster. That could be a goal, but anything that's critical or high probably should not go out complete, and that should be blocked. Same model we did for Angular builds. You build the app and then you run an npm audit. Audit level is high. Like I said, this is a starting. This is a small app, so we are just using the high mode, and this mostly because this is for internal purposes only. So that kind of works for us. But if you are using external, if you are like you asked earlier, if it is more for like any compliance oriented, you have to target those compliance and enable it for that particular thing. Again, you have the scripting modes. It can add the reports in a format that you want to present because developers will be looking at this pipeline. They need to understand what kind of bugs created out of it so that they can address it. And that's where you have this script, or you can enhance this with these scripts so that you present it in a manner that developers can understand. And lastly, the fourth thing that I wanted to highlight here is the alert tools. Release apps, but if you don't know if they're failing in production, then it's again very risky. That doesn't fit your platform model. That means you're one of your core elements, which is observability and monitoring. To impact to your DORA metrics, you need to have an observability so that you know if your change is failing. You have to redo that or you have to roll back to it. For that, you have to have a proper observability system, your SLO targets, and all. Now, here I've put in like the generic ones, like we have 99.9% uptime, and P95 less than 2 seconds, error budget, that you can always align to whatever your enterprise standards are. I gave the context and alert philosophy. How do we use it? Again, that is sometimes very different in different organizations. You can add your own alert philosophy here. No, the task is what I want to do is get a high error alert rates, API availability alerts, database connection failures, and all, and some warning alerts. Again, if you give it freehand, and the reason for adding it in this way is if you give it freehand, you'll get 100 alerts, and that's not going to give you any information. It's more of a noise rather than a signal. So start from small and then expand it when you see the results and when you know that which feature is critical. Biggest problem currently in industry that most of the companies will be facing with observability is the signal to noise ratio. And that is where they wanted to optimize it, because otherwise your Slack team and all this will be bloated with a lot of alerts that you don't know what to do with that. I gave some examples how to do that, some of the key examples, how to do that. Again, you don't need to write it on your own. You can generate some of these examples, again, using the chat. What kind of output format that you need. These prompts look exhaustive, like it's very big, but again, this is not something that you write on your own. Most of these parts, the critical part here is the alert tools that you want to create. What do you want to achieve out of it? And what is your philosophy of these alerts? That is something only your enterprise knowledge is. Rest all is just schemas. You can give the structure of the biceps. You can give TQL queries right from the internet, or just ask the chat to generate it for you. Now, what we're going to come up with, you have this entire same bicep module that we were looking at earlier, but now you can add the critical insights. So you have Microsoft Insights that you see we are using application insights. You can add the GS receivers, SMS receivers, who are going to get it, all these notification groups. Same for the email receivers, and then you add these alerts. Who is going to be for each resource? What is the kind of alert? What is the evaluation frequency? 5 minutes, 1 minute, 2 minutes that you have to do, and we can fine tune it based on your request and workloads. And start small, keep expanding it over the time. It will become generic. You add templates to it, and then you don't need to kind of like bake this like 1,000 lines alert bicep. We can just feed it with the variables, and it can still take it the same way for each of these critical API endpoints or services.
I love seeing how you're layering all of this and then continuing to build it up for us so that we have multiple levels of observability and protection, the security to go along with what we saw before, right? With the documentation, the deployment, and the testing.
So a quick question from the chat area, if I can. When we have seen multiple incidences recently about attacks on the software supply chain, right? And so the security scanning that you're doing makes sense to catch those things if there are known vulnerabilities, if there are CVEs or otherwise, prior to deployment. How do we, in platform engineering, put in the diligence to make sure that we can handle it as a post-deployment? It's already out there, but now we've become aware of this, that we have a vulnerability.
That's a very good question. And what we're seeing right now is kind of like static checks. And these are not the checks that happen during when the system is already deployed. So this is all when you do it before deploying. But when you reach your system to deployment, it doesn't mean that you can't do anything. So for that, the category of security tools that we use is mostly around the dynamic assessment or dynamic security tools. There are different categories of it. If you're running it in Kubernetes, you can use tools like Falco that can run runtime checks, make sure that nobody is kind of like trying to exceeds its own privilege. Like currently we are using containers. The biggest problem with containers in the early days was people can escape out of that because it's just a kind of like a shell or a root user within your major operating system. So if people escape those privileges, they can just get your host access, and they can then kind of like make everything hosted. They can do anything with any other apps. And that's where these runtime checks comes in. They make sure that we have policies defined over there as well within the cluster, that nobody is allowed to escape out of this. You have RBACs enforced that a service can only communicate to X number of endpoints to other service. Again, that can be done at like cluster level, VM level, and all. You can even do host tools as well that are kind of like managing the identities, what is installed over the hosts, so that you know what softwares are installed on the host, and nothing is kind of deployed from there. So all these tools that we have seen, these are pre, and same goes from the host side as well, dynamic scans as well. Whenever your systems are running, they generate real-time alerts. Anyone trying to breach that, kind of try to increase its privilege, they kind of throw the same alerts for it. Lastly, I'll just quickly show up the last layer because what we have seen right now is more of like static checks. You create these policies, you create these rules, but how do you enforce it? It's nothing valuable if people have a way to just comment it out, escape out of it, and they can just use it, right? And that's where your policies comes in. You have to, as your example is as your policies, you enforce that people have to create these tags. Without that, the resource cannot be created. So even if someone tries to kind of comment out our efforts that we did in the bicep, this policies can still make sure that, hey, you're not allowed to create those things. Again, doing it in bicep, you have to analyze and all. You can just write it out into these prompts that I need probably minimum SKUs, allowed Azure regions, and required resource tags. These are my 3 policies that I want to create. And it will basically create an Azure policies that we see in our first biceps, and it will go into the Azure policies and kind of create all these policies for you. So you need these kinds of tags. One of these, dev, test, prod. And if you're running into the regions, then these are the allowed regions that you can use. You can have policy rules. Again, a lot of people might feel this is more of like an infrastructure side, IT admin teams have to do. But that's what we are trying to bring in from the platform mindset, that we need to make it more self-service. So you can even enforce it. You don't need like a strong or big bad IT team to do that. You can create these policies, rules, so you can enable it as early as possible in your development journey. On the release side, we said we are releasing faster, but how do we release safer? There are multiple models of deployments and releases. You use Canary, you use Blue-Green, A/B testing, and all those stuff. But one of the examples is Blue-Green deployment. And if I just see quickly how it does, if we are onto this app services, they have this slot feature. They create slots. They have staging slot, production slot. You release it in staging, make some testing over there, all the health checks pass, API endpoint parts. Again, tying back to the observability, health check, security that we did, everything passed in the staging. And then we kind of move it to production. And what was the previous version becomes the backup version now. And the same process goes back and back. You release new feature, the existing feature becomes the backup, and the new feature becomes the live. That is usually the ideal stage every company wants to be. If they have budgets, they want to kind of release in the Blue-Green environment, nothing impacting what is running already. And what we were doing right now with Bicep is something same, kind of like create these rules, create these slots. We can bake into the Biceps as well. So same way, create these documents, create the ADRs, get it approved, and then you can work on this coding, use these AI-assisted features to enhance your Biceps, test fast, and then kind of release faster. That's all I wanted to show on the code side. Any questions, David, Tim?
No, I think that was That was great. And I was just about to ask, what does blue-green mean? But you did an excellent job explaining, where we can have the new code and the existing in place so that we can validate and verify that we're up and we're going and still have that safety net. Loved seeing that. One of the other things that you mentioned as you were talking in the beginning about developer productivity metrics was DORA. So talk to me a little bit more about how you decide what are the metrics that you're looking at. Because I know there's a couple different ones, right? There's DORA, there's SPACE. How is it that you decide what it is you're looking to measure to know whether or not you're being successful from a platform engineering perspective?
Why DORA? Because usually the goal of the platform manifesto that has been was to kind of reduce the cognitive workload on developers. And usually in the generic space where we have these different team topologies model where we have a platform team, then we have an enabler team, and then we have these features or teams verticals. Someone is building like checkout model, someone is building out the skill role mapping feature, someone is building an integration with the external tools like learning portals and all. Now, all these people will come back and use these enabler teams or work directly with the platform teams to create like a product as a service model internally. For just one product, you create multiple product as a service model. So ultimately, where DORA metrics or all these metrics that align well is you have to release faster and you have to release safer. Now, having said both of these things, it cannot happen when you don't have like these workflows or these strong platforms baked with these ideologies that you have security, you have governance, you have infrastructure as a code there. Because without this, you cannot enable this. And that's why all these metrics, bottom line is tied back to these core elements that you have these in place first, and then probably you can even talk about platforms so you can work in that direction.
And it does a great job, like you said, kind of standing between the team delivering what it is we need technologically and the value that the business is really trying to capture.
Lastly, I'll just highlight some of the trends that we are seeing with this AI power platform. I think like we have already seen, it is moving more shift from manual to AI assisted infrastructure. Like we have seen some of the examples of how we added observability, security, health checks, incident management, and all. Policy as code, like we've seen the last part, that has becoming default standards. You don't have to do a lot of yak-shaving to do that or enable that, go back to the IT teams and all. Self-healing autonomous operations, again, no need to learn a lot of tools. All these standard alert tools, schemas, KQL, PromQL, all these are things that LLM already know. Use that to create more efficient alerts, improve your signal to noise ratio, and make more operations more autonomous. And ultimately have developers to self-service at scale so that they can go out and build more features, release more features, and can bring definitely the benefit on the development side. Architecture documentation, we have seen the first part. That's really the biggest thing that anyone can start using from today. Don't rely on someone to give you a session on what it is. You can just use this to understand what the code is and create your own set of documentations.
So thank you, Aman. That was awesome. I appreciate you walking us through all those different aspects and walking through the layers of understanding and documentation, like you said, the implementation, the infrastructure and testing, as well as the safety and the security, right? The repeatability that we get through lining all these things up was really great to see. So just a reminder, we have upcoming, our last session will be October 29th. Rich McCraw is going to be joining me to talk more about data engineering, analytics, and insights. So what it is we might be able to gather from all of the things that we have inside of our Engage platform as a consequence of adding this feature. Don't want to miss that. So I hope that you'll join us at noon Central Standard Time next week. In the meantime, thank you again, Aman. Thank you, team and Tim, and we'll see you then. Bye.
A quick note to those who regularly attend our series here on Wednesday. The platform will be changing over the next month, moving from Zoom to a new Teams platform. Should only change how you register to come and attend us, but we did want to give everyone the heads up that it's if you see it as a Teams link going forward instead of a Zoom's link, that's planned, and that's part of what we're intending to do on a go-forward basis. Thank you again, David and Aman, for today's session. I look forward to the last session next week in this series before we launch our November series with Fanfare the week after.